Hey guys, it's BlockchainBrad, and today we are talking about what is arguably one of the most exciting blockchain projects in all of 2018, and that is Quarkchain. And to do and better explain this, we have the founder of Quarkchain. His name is Zhou. So Chi, thank you so much for your time this evening.
Yeah, nice to meet you, and it's my great pleasure to talk about Quarkchain here.
And certainly we are very excited to hear about it. There's so many things we don't know, and you are the best person in the house, in the seat, to explain that. So, Chi, obviously there's many things we don't know about you. You've been busy in the background trying to create this. You have experience as a former Googler with 15 years experience in developing and engineering. You have a PhD from the Georgia Institute of Technology. And what is simply interesting is that you have achieved many outstanding awards in your career. So could you tell us a bit more about why you are the best person to lead something like this, of this scale, no pun intended, to really challenge the things that are happening in blockchain?
Sure. So I started writing software when I was a high school student and started to the industry. And then I continued writing different kinds of software. And one of the software projects actually was awarded by Bill Gates in personal.
Right.
And so my PhD was working on high-performance algorithms to address some NP hard problem. And then after my graduation, I joined Google and worked in Google Fiber for Google's next generation network infrastructure. Mm-hmm. And then I moved to DSD, which was acquired by EMC with $1 billion.
So that was $1 billion.
Like $1 billion, and yes.
Wow.
And then I was one of the key developers in their high performance project that is able to deliver 10 million IOPS.
Wow.
Yeah, over 2 x86 blocks. And then I moved to Facebook, work on real-time infrastructure, which is a team that basically delivers all the real-time messages at Facebook in worldwide scale.
So you're really experienced in the area of scalability particularly, and you've worked, as you said, in Google and in Facebook, and now you're moving into your own core design and architecture. So let's talk about that in the context of it. So Quarkchain, that's the name, but what is it? Let's discuss this and unpack it as if someone didn't know anything about it, as a beautiful and simple nutshell explanation.
So Quarkchain is a blockchain, permissionless blockchain that aims to address the blockchain scalability problem, which is one of the most fundamental problems in blockchain. So it is decentralized, secure, and also scalable permissionless blockchain, which adopt a lot of technology, mature technology from centralized world.
Right.
So yeah, and it actually there are a lot of it's essential technologies called sharding, which is basically one of the most popular technologies in the centralized world to address the scalability. And Quarkchain basically built on top of the core values of the blockchain, which is decentralization and security, and at the same time carefully and selectively choose all kinds of technology in the centralized world like sharding and put them on top of the blockchain so that we can achieve great scale.
I see. And as we talked about with your background, this is really the secret and what sets you apart, in that you have brought all of your experience from the centralized world of business, and particularly in the scalability areas of software design and engineering, and you're bringing that into the blockchain so that you're bringing the best of the two worlds together, but really using the core values of decentralization to build out your plan.
Yes.
That's very interesting. Well, let's talk about now some of the key features of your design. Obviously, that's very important. Let's start with the peer-to-peer transactional system that you've built. Why is that important to have it in such a design?
So right now, like blockchain, for example, Bitcoin, Ethereum can achieve roughly 10 transactions per second. Like Bitcoin is roughly 6, Ethereum roughly 15. And while compared to centralized transactional system, like for example, Visa and Alipay last year is able to achieve 200,000 transactions at their peak time.
Okay.
So
that's a centralized system, as you said.
Centralized,
okay.
Yeah. So And Alipay actually is a transaction, just also this payment.
Sure.
So doing similar functionality as Bitcoin or Ethereum. So there are a huge gap between that. So I believe there are tons of space in this area for centralized world to scale greatly, and so that we can put a lot of decentralized application on top of it.
I see. So the buzzword, I guess, for your design is the high capacity. So let's move across a little bit to the kind of capacity you are creating right now to set yourself apart from the original iterations of blockchain, which are such as BTC or Bitcoin and even Ethereum.
Yeah, so basically scalability is I would say there are two directions of scalability. One direction is basically vertical scalability, which basic idea is to improve the performance of the single blockchain. For example, Bitcoin to Litecoin reduce the block interval, and then Bitcoin Cash increase the block size, and also Ethereum also decrease the block interval by using like Ghost algorithm. And that's one direction.
Right.
Another direction actually become very popular these days is basically, I would say, to scale horizontally, basically to have multiple blockchain run together and work close together, while at the same time we can still achieve some security.
I see.
Now, one of the popular projects now is Ethereum sharding, and also Zilliqa. And so Quarkchain also using the vertical horizontal scalability, like using sharding technology to greatly improve the performance. And also the vertical scalability and horizontal scalability, they are not in a working in a mutually exclusive way, but they are helping each other. So once they are a breakthrough in the vertical way, then horizontal scalability can also use them to improve the system performance.
I see. Well, let's clarify that now. You've made clear that you're going to combine both the vertical and the horizontal scaling solutions. But let's talk about that in the context of Ethereum. What is the role of this vertical, this single blockchain, in your design as you parallel scale and as you use concurrent systems? Where does Ethereum fit in? Is it Ethereum or is it actually their virtual machine?
So basically we are running out of blockchain built from scratch because according to our scalability experience from centralized world, once the system cannot be able to satisfy for example, user growth, then the best way is just rewrite it.
Right.
And so we build all the things from scratch by ourselves, and then but we also borrow a lot of goods. Benefits from like Ethereum and Bitcoin. I will say salute to all these existing technologies which make Quarkchain to move much faster. One of them is Ethereum virtual machine. So we borrow the virtual machine and build on top of us, so then can easy to run any the application that built on top of EVM.
I see. Well, thank you for explaining that. So just to clarify, you are very much your own blockchain design. You will have your own dApps as well, but certainly currently you're using the EVM. So let's explore this in the sense of permissionlessness. Because obviously Ethereum, again, is a permissionless design. You are, I understand, the same. So what does that mean for the audience who doesn't know potentially what the value of permissionless designs are?
So a great value of permission is that everybody is able to join the network without say, hey, register a user account or need to have some balance, as long as the user have sufficient hash power, and then the user is able to join the network and contribute to the network, and then collect corresponding incentive from the network. So I think this is very important for a public blockchain.
I see. Well, let's now talk about the difference between on-chain and off-chain, in that you're trying to do an on-chain sharding system. So why is it so important to do this on-chain when traditionally that requires more computational power?
Yes, because the on-chain transaction has a lot of flexibilities, including what kind of transaction can be performed, and also it has great security because it is almost unchangeable.
So immutable?
Immutable after finalization. So there are a lot of benefits of on-chain transaction, and everybody easily believe now this data in the ledger is being protected. So that's why we want to make this on-chain capacity to be greatly scaled, so that everybody in the world is able to use the blockchain anytime.
I see. Well, obviously, to create something this broad and this large, of this scale, again, no pun intended, but there must have been some problems in the current models that you saw, not just in the centralized world, but also in blockchain itself. So if you could tell us just a few, what were the fundamental issues or problems you foresaw when you started to create this that you really are trying to resolve?
Yeah, so I think several fundamental issues is that a lot of blockchain system, when they, like for example, Bitcoin, basically it is not designed for scalability at the beginning. So Bitcoin have a lot of innovations, but according to our experience, the scalability must be designed from the beginning. Like for example, like Google's big table of files, Google file system, when they target for scalability and they are able to scale. And so I think this is one, especially in early blockchain stage, I think there's a lot of difficulty to make them the scale. Yes.
I see. So just obviously I wanted to ask you about your experience in Google. Do you see, with all of the knowledge you have, that even Google could potentially benefit, or the kind of model that they have, with transitioning into something like Quarkchain in the future?
Yeah, I think that's possible. I think like a lot of ideas, actually, I borrow from thanks to Google's and Facebook's ideas on scalability, and also I'm feel lucky I have a chance to closely work with them. So definitely I will say that, like, based on this top of this infrastructure, I think also like many applications, like for example, Google and Facebook developer can also benefit from that.
I see. Well, let's now talk about your very unique two-layered design as well, Chi, because it's, again, something that is setting you apart. Can you tell us exactly what it is and why you designed it in this way?
Yeah. So the first way comes is that if we want to scale like horizontally with multiple blockchains using like simple proof of work, then we hit the so-called hash power dilation issue, because suppose there are 100 blockchains which runs in parallel, then with the same like proof of work difficulty algorithm or hash algorithm, then one of them will have a most 1 over 100 hash power, which means that any attacker with 1 over 200 hash power is able to dominate that blockchain and then revert any transaction as he wants.
I see. So there's a potential for malicious activity in that respect.
Yes.
Okay.
And that's why we come with the called two-layer blockchain. So basically we still have the multiple blockchains runs in parallel, as we call shards. Meanwhile, there's called a root chain, single root chain, that with sufficiently high hash power, with the purpose to protect all the transactions in the shards, so that every shard, even though it has a relative weaker hash power, but all the transaction is still protected by a very strong hash power on the root chain.
I see. And the way you've designed this, obviously, you can have infinite number of shards, potentially, as you build the capacity. Is that correct?
Yeah. Right now, we support up to 2 billion shards in the system.
2 billion, that's quite a lot.
Yeah. But we expected we are going to support like thousands of shards in a short term.
Yep.
Yeah.
Okay, so a lot of potential is there in your architecture. What about in terms of other features? For example, your guaranteed security with regard to your market-driven mining capacity as well. Let's talk about security measures as well and what you've designed.
Yeah, actually the security is highly tied to the two-layer design with the root chain. So basically what it means is that attacking any transactions must also attack the root chain, which have strong hash power. So which this is why the root chain has corresponding hash power is a result of we call collaborative mining. Actually, the collaborative mining actually it means we design kind of the incentive and difficulty way so that every miner just mine for their best benefits, but the ending result, a collaborative result, is doing the benefits of all the miners and all the peoples in the network.
I see. So there's no centralized mining mechanism required in this respect.
No.
Okay, that's quite innovative. Speaking of innovations, you are doing some world firsts, arguably, 3 of them in fact. The first one I wanted to talk about is how you address the issue of sharding via state sharding. That really is something quite innovative. So can you tell us a bit more about that? And specifically with regard to state, storage, or transactional, what exactly are you doing that sets you apart?
So let me clarify a little bit of state sharding, because I think different people have different understanding of what state sharding is. Also, there are people asking the same question in in Telegram regarding state sharding. So basically, my understanding of state sharding is that there's a node that only need to process the data within its shard, so that it only need to save the corresponding storage or corresponding shard. Because when the transaction goes high, there's several bottlenecks there. One bottleneck is storage, because in order to be able to access so huge ledger that create because of the high transaction per second, then we have to split the ledger to multiple nodes, and each node just store the corresponding partition of the ledger.
I see.
And so in our system, we achieve this using clustering, which is a very also common topic, advanced topic in the centralized world.
Right.
That basically able to partition the whole system ledger into multiple nodes and then collaborate together to validate the whole ledger of the network.
I see. Well, can you explain that a little bit more in the context of supernodes? Because obviously there are some problems with that design in comparison. So let's discuss that and compare that to the multiple node system that you're creating.
Yes. So a supernode actually is the same term as a full node in the Bitcoin. Basically, because we call it super, because in the network with high transaction per second, a full node that able to process all these transactions and ledger must be very powerful. And that's why we call it super node. There's both in terms of CPU and also in terms of storage, which I just mentioned, and also network memory. And that super node that becomes a classic vertical scalability problem, because in order to achieve a 10 times or maybe even more performance on a single node, in general must be pay much higher cost, like maybe 20, 30, or 40 times higher price.
I see.
And that's the beauty of the horizontal scalability, and also sometimes people call it linear scale, which means that if people want to achieve 10 times performance, probably only people need to pay 15 times cost. I mean, if people want to turn times 20 times performance, it just times twice, that's 30 times of the cost. So this is a linear scale. And so for us, we want to enable this linear scale so that we are able to use several cheap nodes and put them together and then to replace called a superfull node. So that we want to dramatically reduce the cost of creating such superfull node.
I see. And that's obviously something really is quite innovative. We haven't seen that yet. With regard to another innovation that really does set you apart, and that is your Turing complete smart contracts. Now, obviously you alluded to Zilliqa before. There's a few very clear distinctions that we'll discuss in terms of Turing completeness generally. But really, why is it so important to have Turing complete aspects of design?
So I think Turing complete is, I think that's thanks to Ethereum. I think that's a great innovation that opens a lot of possibilities, because all our program is actually Turing complete. That means any kind of the applications we are able not just ignore the cost of blockchain, but we are able to run on top of blockchain. And so. So in the meanwhile, I mean, supporting tooling complete, like for example, Ethereum virtual machine, we are able to like let a lot of existing the applications that built on top of EVM, but they have a very strong requirement on the transaction per second, is able to directly deploy on top of us and now enjoy the benefits of the scalability that Quarkchain brings.
I see. So essentially, we're talking about cross-chain compatibility, cross-chain, interaction, and more importantly, there can be a conversation between the dApps that run on Ethereum and your own design. Is that correct? Is there potential for cross-chain collaboration in some sense because you're utilizing the EVM?
Oh, I think that's possible. We're also looking for any further collaboration, both from Ethereum or any other blockchain regarding
the future.
Cross-chain. The future, like cross-chain or any kind of transactions.
I see. And I would imagine it's quite likely, given that your proximity to Ethereum, utilizing EVM, no doubt the first point in which you create a cross-collaborative approach would be with them, I would imagine.
Yeah.
Okay.
Yes.
Well, let's talk about now your final point of innovation, and that is, as you mentioned, your clustering system. Can you explain to us essentially why you are the first network that supports clustering as peers?
So basically, a cluster is a centralized way to address the scalability problem when a single node is not able to afford the corresponding performance. That's how also Google, Facebook is able to deliver their service at a worldwide scale. So we bring the same idea to the decentralized world. And then the basic idea is still to replace the full node, super full node, with this clustering. So that we aim to reduce also the cost, so people doesn't need to pay a very expensive machine at upfront cost, and just gradually add more machines once the network transaction goes high, so the more people can just join the system very early stage.
Okay. Well, with regard to your actual architectural design, your fundamental, core, no doubt you have a very specific consensus algorithm. Can you tell us specifically what that is and why you chose it?
Yeah. So our main innovation is in the terms of scalability. So that's why we would like to adopt some mature consensus in the decentralized blockchain world, so that we can reduce our risk. And we also would like to adopt several mature consensus in the future to enhance our performance. And second is that in order to address the scalability problem, we have a very special proof of work consensus. So basically, the root chain is still running on the standard proof of work system like Bitcoin and Ethereum. And however, for each shard, it runs a special consensus called root chain first consensus, which means that if there are two forks on each shard with one fork even longer than another one, the longer one may not override the shorter one, because the longer one is not being confirmed by the root chain.
I see.
In such case, we are able to make sure that if a transaction is confirmed by the root chain, then any attackers must revert the root chain before reverting this transaction in the shard.
I see. So obviously you're utilizing some sort of hybrid of proof of work. So in that respect, Chi, can you tell us a bit more about how you would address the forkable nature of traditional original blockchain designs that we've seen?
Yeah, so I think adjusting the fork, one major is to given two system state or ledger state, which one is longer, which one should be survived or which not. So thanks to our root chain consensus, we can, given any like blockchain state, we can easily tell which one should survive and which one should be discarded. And that's also the one critical part of the consensus in the proof of work based consensus.
I see.
Yeah.
So obviously there's many different aspects to design. Three of the things that really set you apart are your cross-chain transactions, your simple account management, and your, as you mentioned before, your market-driven collaborative mining. So we won't talk about the mining, you've made that very clear, but let's now talk about the other two. The cross-shard transactions, why is that important?
Yeah, so let me clarify a little bit regarding what's the cross-shard and cross-chain transactions. So basically, I would say cross-shard is a kind of cross-chain transaction, but each chain is more homogeneous, which means that they are running on similar, actually the same currencies, so that it will be much easier to transfer because there's no exchange rate issues, and so much easier to transfer different currencies from one blockchain to another one. So we support scalable and also efficient and also secure cross-shard transactions. The basic idea is to be able to a user when want to access the resources on any shard, what it does is just to move its balance from one shard to another shard and then perform corresponding transaction with that resource, like smart contract.
I see.
Or,
now,
or another user account.
I see. And what's innovative about you is that you can do all of this management system using one single account, which is something we haven't seen. With one private key, you can do everything with your smart contracts. So can you tell us a bit about why that really is something that must have been a lot of work, but again, a feature like no other?
Yeah, I mean, that is also one of our major innovations, because with different shards, then I saw a lot of existing solution basic partition based on count, and that creates a lot of issues, like, for example, how to perform cross-shard transaction because of need to guarantee the atomicity of the system state across shards. And so with our design with this single account management with one single private key to access to manage all the basically all the address of that account in all the shards. So user just need to move its balance from this shard and just perform the transactions in that shard.
I see. That's very exciting. And obviously there are some graphics that you can see in the white paper that really explain this. If you'd like to know more, that is one of the key innovations of Quarkchain. Well, let's now talk about some of the incentives in terms of your overall reward system. You mentioned it's proof of work. With the proof of work comes with rewards. How does that factor into your design?
Yeah, so first we are using ASIC resistant proof of work. Nowadays, I mean, people have a lot of technical debating because there's a lot of ASIC miners that make the system more centralized. So we definitely would like to encourage more decentralization to adopt the ASIC resistant proof of work algorithms, hash algorithms. And second is that we also encourage, because we have a shards with weaker hash powers. So basically we encourage more decentralization so that the miners are able to just mine the shards directly without joining a miner pool, so that they don't need to pay the corresponding transaction fee in the pool.
I see. So in that respect though, how, with your incentivization system, how do you ensure that there's 50% of the hash power is running on the main chain as well?
So there's a corresponding incentive design and also difficulty algorithm that put them together to make sure that there are 50% of hash power on the root chain. And also we have some network simulation to help us understand in different network configuration, like for example, different kind of incentive and different kind of difficulty algorithm, what is the dynamic of the network, so that before we deploy our network, we can easily know what's the simulated results of these parameters, like difficulty algorithm, all kinds of this.
I see. So that way you really do ensure against any sort of malware attack of any kind.
Yes, like
Okay.
double spending attack.
Yeah,
Like that.
yeah, which is really important because we've seen that happen in the first beginnings of blockchain design. So, with regard to security, again, you've alluded to some of these key things, but what would be, if you could tell us in a nutshell, your biggest features to really truly address security on the blockchain that really does set you apart from other designs previously?
So I mean, it's still the key is that this two-layer design with this collaborative mining to ensure our security, and also with our design, we can create a lot of shards without like a lot of limitations. As long as there's a sufficient hash power on the root chain to protect all the transactions.
Okay. And also, Chi, with regard to applications, being your own blockchain design and architecture, you're going to have apps run on that, known as dApps. So what is the plan? Let's unpack what is the potential really of this kind of scalable enterprise solution, and just who could use this?
Yeah. So I think actually I also read a lot of white papers, and there's a lot of the applications that they are actually being, they have ICOs, they are basically building their software, be able to deliver their software on time. But one major, I would say bottleneck hurdle is that they require some scalability on the underlying public blockchain. So basically we welcome this kind of the applications to build on top of us. We will quickly release our test nets and with some good numbers. I won't disclose it right now, but so that this like software can be just deployed to us and see what the performance is and how they are able to utilize our platform to enhance the scalability of their applications. So that's one direction. Another direction is that we are also actively contacting traditional ITs because they have a lot of requirement in terms of like blockchain, which blockchain is able to address a lot of problems. And so we are also would like to collaborate with them. We also have talked to more than 10, I would say maybe 20 or 30 company like this, and then discuss what's the next step, how to align their plan with our testnet plan.
I see. Well, let's talk about now industries as well, Chi, because you've mentioned that there is obviously a lot of things happening in the works with just exactly how many dApps we don't know, but clearly quite a few that you're planning. But in terms of industry, there's allusions to things like gaming, to IoT, to AI, and advertising, and so many more, even in finance. So really, is it fair to say that you're going to essentially be cross-industry? You're going to operate with and satiate all of those industries with the potential of your blockchain to address the needs of all kinds of business?
So we're target as a general blockchain. For example, like tooling complete smart contract is like a need for a general blockchain. And then with this tooling complete feature and also great scalability, I mean, we can address a lot of these problems. I think you just listed like decentralized exchange, gaming, also advertisement, maybe social network. And we see that this kind of scalability way is also be able to apply to some narrow like applications, like for example, just dedicated for fast payment, or some application that doesn't require this strong feature, but maybe for example, more in some vertical way. So I think there's a lot of space.
Scope. Certainly a lot of scope. And clearly, the big thing that's setting everything apart right now is scalability. So there must be many enterprises knocking on your door because finally you're opening the door of blockchain to real world potential for business to operate and even interoperate arguably in some time. So let's talk about that in terms of business interest. Tell us, as the founder, what kind of conversations are you having? Just how big are these businesses are knocking on your door, Chi?
Actually, there are several I would say business partners. They are actually we have discussions, and basically every week I have several people from different sectors that visit us and discuss potential collaborations. So because this is still in pretty early stage, so not sure it's able to disclose a lot of this.
Well, what I do appreciate though is that you're already showing us there's a lot on your books in terms of interest and preparation, and more importantly, business on the blockchain, on your blockchain. So we do really appreciate that, Chi, that you're building something real for the real world, and it's not a play thing, it's not theoretical, it is going to be applicable.
Yeah, because we are engineer, and engineer is to write the code and make it work.
And are you confident that this is something that can really hit the market running, that it's something that can be operational very quickly, even this year?
I think that's possible. So right now we are in a closed source stage.
Yes.
We want to finalize all the details and provide early design and also early implementation of clustering, all the key features. And once that is being well tested, actually we have a testing program that started next month.
Yes.
And the end of next month. So once that is ready, then we are ready to open source, and we welcome all the people from open source community to help us to make it work. There's a lot of tons of space can be improved. They definitely have some bugs, and they also have some like performance that can be optimized. And so I think that we need great help from open source community to help to put together to achieve this great goal.
Well, speaking of that effort and endeavor to engage the community, I understand that you did have an initiative of bringing in 100 different community members to experiment with the code. So let's just explore that for a moment, because we don't want the audience to suppose that you don't have code because it's closed source. So what can you tell us about just the size of the code that you've created?
So right now we have more than 10,000 lines of code, just complete built from scratch.
That's a lot. How long did that take?
Actually, we started from early this year, but the most difficult part is design of the system that we started from mid last year, and we have a very fierce debates and discuss of what should do and what should not do, and what is maybe sacrifice decentralization, and what's the better way to address the scalability. But since we are experienced developers, once the idea is ready, the design is ready, then we can just move as very fast.
I see. And obviously, you must be very proud of the code you've created, and now people are experimenting with it. How has the feedback been so far from these people interacting with the code?
So I really appreciate all the code reviewers, third-party reviewers, to review the code and discuss all the ideas, and also figure out a lot of comments. And to my, maybe I'm not sure surprised, but almost every people that review the code, go through all the tech dev, just immediately say they would like to help me, they would like to more contribute to the project.
I see.
So
they're very optimistic and very, very much excited.
Yeah.
That's fantastic. It's good feedback to hear, and we like that you have actual code. And when do you plan on releasing that in an open source design or open source sort of release?
So we plan to release it in the middle of this year, depending on the two main features. That one is clustering, early clustering, also the smart contract we want to put them together. And once that's done, then we are ready to open source. Okay.
Well, as you say, we, obviously referring to a team. So let's discuss that. You have two key teams in your, your design, and that is your development team and your operational team. So can you tell us essentially why you did that, and in a nutshell, what really showcases the skill sets of your teams?
So for engineering team, right now we are focused on our infrastructure. So we are basically most of the skill set is underlying infrastructure, for example, clustering, and also definitely blockchain knowledge, and like and for example, contribution to reading a lot of like Ethereum and Bitcoin code and understand all the details. That's the one requirements. And so another is from our marketing, and basically we want to, based on our results like testnet, all kinds of things, we want to let people know, hey, we are doing this, and we welcome people to help us to contribute to the project, to make it better, to make it more higher performance and more robust. So basically we are that's why we have these two teams, and we closely work together.
I see. But let's talk about now your advisors, those who support you. You have some very impressive ones on your list. Aaron Fadke, for example, is a brilliant example of this, with his experience as a professor, an emeritus professor in the Department of Electrical Engineering at Virginia Tech. So your advisors are the real deal. But how engaged are these advisors that you have?
So a lot of these advisors, they are either my boss in my previous company.
Right. Okay.
Yeah.
That always helps.
Yeah. Also, they are also my friends, and also my close friends of my friends. So basically, we know each other, they know what we are doing, and they are very interested in it. They also would like to help us. And then we also carefully select their background to make sure that like they are able to help us in different aspects, like in terms of technical, in terms of like how the company, how the organization should be, should work together, legal, all kinds of investor relationships, all kinds of this.
I see. Well, in that respect, obviously you have a very robust team, but how many do you have in your teams collectively? If you consider the devs, the engineering side, the overall numbers.
So basically, our full-time people are roughly 6 to 6 full-times, and there are 3 or 4 part-times. They are like working in the team.
And that's quite impressive, given that you haven't completed your ICO. So you've really had to rely on the funds you've created so far to build this team. So no doubt you plan to really build this out once you finish your ICO.
Yes.
That's exciting.
Yeah.
I mean, well done already to have that many people. If I wanted to ask you about your plans in terms of technology, you spoke of before the importance of decentralization, but that couples so beautifully with the new generations of, I guess, technological users who are engaging in that way with even mobile phones. So clearly you want to focus on technology as a means of engaging people. And one of the things that you do profess to do is be more mobile focused. So can you tell us a bit about how that is the case?
Yeah, so I think right now like mobile actually is more like I use more time on mobile rather than computer these days. And more people are using more mobile. However, we feel that the blockchain technologies, because it has some requirements on how to, for example, run the node, maintain the ledger. I think there's a lot of like connections with the mobile with blockchain is not well established, and so we want to mitigate this gap, and so that the mobile is able to a lot of application that can use the D application to build on top of blockchain and put them together to like complete a lot of these features that we never think or imagined before. For example, now there are a lot of popular payment systems like Alipay or based on Apple Pay, and so many of them, because they are very high transaction properties, so that running this like on top of blockchain is very hard. But now with these new technologies, then we are able to also perform some kind of this just real-time transactions or payment just using mobile, just scan a QR code or scan something and then now your transaction is on blockchain.
See. So really you want to make it completely accessible. You want to make your blockchain accessible through the best technology innovations. And obviously part of that is making sure that people can access it with their phone. So let's talk about competitors. We alluded to these before, but I wanted to get really specific about this with one in particular, and that is Zilliqa. So clearly Zilliqa is a competitor, but what sets you apart and why?
So I think Zilliqa has a lot of make a lot of innovations and contributions in the scalability and sharding, and so also they achieve some good numbers these days.
Sure.
But for us, we are more focused on like general purpose blockchain with tooling company smart contract, while Zilliqa have their special smart contract that is, I believe, they have some specific task. So I think that there's a huge market in the scalability and also for the blockchain. So I think there's a different like positions for both Zilliqa and us in this market, and actually in some ways we can also help each other to make this market become greater.
I think it's a very it was a very diplomatic answer, but the reality is that you are faster in your design, in your plan. You want to move to 1 million TPS, and certainly you are Turing complete. So there are some benefits to be more generic, wouldn't you say, with your design?
Yes, that's definitely have some benefits in terms of like general like Turing complete smart contract, and also our like different from that perspective. Yeah.
Sure.
Yeah.
So let's imagine for a moment then that I'm an enterprise or I'm a business. Isn't it more likely that I'm going to approach something that has a more generic design or architecture that's more easy, connected with the EVM, when I choose something for scalability?
Yeah, that would be because, like for example, EVM probably is the most widely supported, and so there are a lot of like compiler solidity and also a lot of like IDE, and so all these existing build technologies and tools can be just borrowed to us. Like for example, when I test my testnet with smart contract, then I just use the bytecode that generated by Solidity and then paste on my network, and then now it works.
Right.
Like,
and obviously, Chi, there's many different competitors out there doing different things to address the enterprise solution of scalability. I just want to address a few of them. So we've mentioned Zilliqa, but we've also have some up-and-coming ones like Dfinity. We know of other ones like EOS with Dan's work, Cardano. We also have Moac, Eternity, and Light. Now, many of them are all claiming to be the enterprise solution or the like with better scalability. But if you could tell us just one thing that says basically Quarkchain is the one, it is the one to really set itself apart from the others.
So basically we are in, probably I mentioned that they are, most of like EOS is more scale in terms of vertically, so make a block rate to be extremely low, like even seconds or sub-seconds. And then for us, we want to open another window in terms of the horizontal scalability. So which means that once the open is open, then actually the system performance is X times Y, which X is vertical and Y is R, which we open.
So it's that that concurrency that's really the big feature.
Yes. Yeah.
Right. Are there any others that you know of that are doing something similar?
To my knowledge, I think Eastern Sharding and Zilliqa are probably the most the pioneer in this area.
I see.
And also there are several, I know like Cardano and also Dfinity, they also have the plan to scale probably horizontal in their roadmap, but I'm not sure what they...
Well, let's talk about it. Let's talk about that in the context of roadmaps. Are you confident that you are going to be the first to really enter into this market, given that you are planning on unrolling this, unfurling this very exciting project into the
actually
world?
we currently have the testnet that is running, and this which it supports most of features like cross-shard transactions, and also be able to support like 8 shards and even more, and be able to run in multiple shards in parallelly, process all these transactions parallelly. So
And currently they're running on 2000 TPS right now and moving very fast to different
yes,
speeds.
yeah, that's only single threaded.
Okay, so what about other key parts of let's say Q3, Q2, 2018? What are the big things happening with regard to, we've talked about your public testing, your test nets. What are the big dates for this year?
I think big day is definitely the clustering, because once the clustering is been enabled, we would expect it will give us some surprising numbers, but we currently haven't concrete number yet. But this is probably a very big part that enables great scalability.
I see. Well, let's talk about now your tokenomics. It's something that very few people actually know completely about. You haven't released a lot of this stuff, but hopefully you will right now. Let's discuss, for example, your cap, your design, your dates and your ICO. Let's really explore even your token distribution model itself. So can you tell us what you know about your whole tokenomic design?
So basically, we currently have money. Our hard cap is 20 millions. That includes all the private sale and public sale.
Okay, and so that's quite low.
Because we just want to have smart money to use less money to make everything work, and also have the open source community to work together to make this happen.
Right.
And also
with regard to dates, let's talk about that. You mentioned that the whole amount of the ICO is 20 million. Whereabouts are we situated in this process of the private right through to the public sale?
Yeah, so we expect to have this public sale the end of next month, or probably early of the June.
Okay, so possibly end of May or early June.
Yeah.
Okay,
yes.
But no specific date set yet.
No. It's hard to tell. I mean, we are actively collaborating with our partners to help us determine the time.
Okay, so you've explained essentially the key date and the size of your cap. But in terms of distribution of your tokens, what can you tell us? What are you able to tell us about how you plan to, address research and development, or even, how much of it you've allocated for for the sale itself? What can you tell us?
So basically, we will try to maintain a very low, relatively low percentage of sales, and then leave a lot of the tokens to our community and open source, like both in terms of mining and also open source.
So you've really thought about the people. You've really thought about consumers and users in the future.
Yes, we are also business so that people can help us develop the application on top of that. So I think this is our major allocations for those. And also for our team members, we have 2 years vesting period. And also we have a much longer vesting period for our foundation to support our future growth.
I see. And also that it suggests a degree of scarcity, because some of these are going to be locked up for a long period of time. But I wanted to talk to you about the aspect. Obviously, you mentioned there's a private sale component and no doubt investors to support your utility. But how do you address the issue of those that tend to capitalize in certain projects by jumping in early, but then when it hits exchange, something very controversial happens with many of them, and we see a sudden rise and a pullback that affects the market?
Yeah, so basically we are carefully selecting our partners. We only open private sale to our strategic partners, and also we explicitly mentioned any sales cannot be used for pool, any kind of resale.
Sure.
And
so
also
you were very strict on that. You really ensured with your team that you explored those who may have been trying to do so.
Yes.
Well, we appreciate that in the blockchain space, because we're seeing more and more of that happen. And no doubt this will, again, cement more stability as you enter into the public domain through the sale.
Yeah.
Okay. That's really interesting. If you could tell us now about the function. Now, what is the fundamental function of your token? There are three words that are mentioned in your white paper. They are your value, your carrier nature, and your currency. So can you tell us a bit about essentially those key points in terms of how you would describe what it is, what it's for?
I think the value of the currency is similar to Ethereum as a gas to drive the distributed applications. So that because that's one of our, like as a general blockchain, one direction we want to make it more applications, especially those that can connect it to the real world, can be deployed on top of us.
Right.
And that's the key. And also, like we are also using this to, for example, to be able to finish, supporting other, like for example, like new features, and also like for example, increase the system capacity.
I see.
Yeah.
Right.
And also to drive the miners to protect all the transactions in the system.
See. So just to clarify as well, you are fundamentally a utility token. You are not a security by design.
Yeah.
So how have you addressed the concern of the SEC, for example, and other governmental sectors or even nations who are supporting blockchain, or perhaps not? How have you addressed some of these concerns that you hear about?
So we currently actively with the lawyers in the United States. We have very experienced lawyers in these areas to make sure that, for example, this follows the regulations not only in the United States but also the world, and also, like for example, have very strict. For example, we don't have syndicate or pool collections, so that we want to minimize also the risk in that perspective. Sure. Yeah. Well, but probably that part is a little bit sensitive, so I'm not sure.
Absolutely, but I really appreciate your response though, because we just need to, I suppose, in this space, get a bit more frank so that people can understand exactly, what the nature of the token is and how it can be utilized as you move into the enterprise sector, particularly in the next few years. With regard to community, though, obviously it's sentiment-driven, as we've seen in the beginnings, and that's always a challenge in blockchain. How have you gone about building your community and engaging with your community?
Yeah, actually, we're currently running Telegrams and also Twitter. And Telegram, there are a lot of people asking questions, very good technical questions, and sometimes I feel, wow, we should hire some of them to help us to make it better.
Well, maybe you will.
Yeah, definitely. And also we are also looking for these volunteers with these channels to advertise. Hey, we are going to have looking for these volunteers for us.
So you really are making a lot of effort, and you have a great website as well that has a lot of information and many white papers, in fact. So are you confident that you're going in the right direction with your community engagement efforts?
Yes, we are pretty confident. I think we are, because we are very high tech, oriented term with a very hardcore technologies, and then we are very confident in what we are doing, but our next step is how to broadcast all this information to let people know, hey, this is what blockchain is able to achieve, and what is key techniques inside, and from to target different audiences.
I see.
And so and so in the long term, we are hoping that more people can able to contribute to the blockchain community, so that the blockchain itself can be broadcast to more applications, and more people can be actual benefit from blockchain.
Absolutely. Let's talk now about some of the more challenging things, your criticisms or concerns, some of the critiques you've heard in the business. Can you tell us about the key things that you've heard, and can you address them?
I think one key thing is that to understanding why, what's the security, decentralization, and scalability trade-off that we position and achieve, because we basically have this some kind of consensus built on top of proof of work, and how the transaction are being secure. Yes. And so people have different thought about that. And so basically need to so basically illustrates the details and tell what's actually. We are very frankly to any like potential issues and any issues that.
And what
and
you're
also
doing
people,
is you're making it very clear that it is possible to have a highly secure, highly decentralized, and extremely scalable blockchain design.
Yes,
Right.
yes. And second, people have question regarding our sharding way to say, hey, why we are state sharding and how to achieve that. And so also we also explain that what's the definition of state sharding and
Sure.
how we do that.
Sure.
Yeah.
And so with the state sharding, sorry to interrupt, but that's not something you coined, but it's something you used to really design your blockchain. Is that correct?
Yes, that's designed at the beginning. Because I would say this state sharding, this term, I think actually is by default in centralized world, because without state sharding, Facebook and Google cannot be scaled. But in the decentralized, because of difficulty, so people have different stages of sharding, but eventually state sharding should be the eventually solution to address this problem.
Sure.
So that's why we put it at the first when it just start at the beginning.
I see. Now, given your experience, obviously having worked in Facebook and in Google, do you think that they should they be rather concerned that you are emerging in the space and in the market and potentially could create what is to be the decentralized web for information and for business that could really transition and challenge and rival these companies?
It's hard to predict, but
Is it possible?
I think it's possible because nobody would predict like internet or mobile will change the world's life.
Right.
So we are also sitting at this time being and see how be a witness and also contributor in the blockchain community to make a lot of things happen. And so I think that's possible. Maybe to have a lot of decentralized, not maybe YouTube or decentralized Facebook.
Right. And potentially all running on Quarkchain.
That would be great, yeah.
Clearly you're very excited about what you are leading. You are leading not only a complex smart contract system, you are leading an entirely new blockchain design. You have your own code with more than 10,000 elements of code already codified and written out and being explored by users around the world right now. You essentially have teams of engineers, you have teams of experts in fields, and you have great advisors. What is really standing out is you can potentially move to 1 million TPS, and you can do that on chain, and you can do that in such a way that's Turing complete. So on behalf of all the people wanting to know about Quarkchain, thank you very much for your time today, Zhou. We really appreciate it. You are the founder of this exciting project, and it's known as a decentralized, secure, and scalable permissionless blockchain technology to deliver 1 million TPS on-chain for the future. We are going to be watching you and watching you unfold. Thank you very much for your time.
Thank you. Yeah, it's my great pleasure.